All right. Good morning, everyone. As Catherine said, my name is Mark Pesce. Now, I want to start off by talking a little bit about work that I did 30 years ago. So 30 years ago, this December, I started to work on a blend of hypertext and virtual reality. Because I didn't think one was good enough. Why not have both? I was going for something that at the time most people were calling cyberspace, although today we call it the Metaverse. And that meant that I was co-inventor of something known as the Virtual Reality Modeling Language, or VRML. VRML became the foundation layer for the first generation of Metaverse applications. And today, it's remembered fondly. There's a lot of geeks out there that will come up to me and say, oh, I did this project for uni, or I bought your book about VRML and had some fun with it. And we all sort of lament that it kind of didn't go the way we thought it might, which is that we were all going to have this great, big, amazing, fully fleshed metaverse. Well, I got to tell you, listening to Daniel yesterday up here on this stage lament about the state of the metaverse, I gave him a hug afterward, by the way, because the metaverse is a hard problem, and we are still not near a solution. My boundary layer for saying we're getting close to the metaverse is when you can have as many people as will fit into the MCG, so 103,000 people in the same space at the same time, everyone fully aware of what everyone else is doing. And if you say, oh, Mark, that's impossibly hard, I'm like, Twitter has been doing that for 15 years. So we need to think about what's possible. In the meantime, I want to talk about what we're going to be doing as we get closer to the metaverse, something that I call the syntheverse. Now, the first thing we have to understand is how much has changed how quickly. Now, most of you would be familiar with ChatGPT. Until yesterday, it was the fastest application to get to 100 million users. Now, we have high quality, not perfect, but high quality artificial intelligence on tap. Now, it's not really ChatGPT here. It's something called GPT-3 and lately GPT-4 as the engines that sit under this. What we need to think about those things as engines that are now being used to power a range of different applications. What I want to do is I want to take a look at 3 of those applications that are emerging right now and show you how they are going to combine in the syntheverse. All right, let's start off with generative agents. So, what are generative agents? Well, for a long time, there's been the desire to be able to create synthetic persona. Persona, in other words, being able to describe the characteristics of someone who is human-like, and then be able to get that character to act in situations interactively as if they were actually human beings. Now, this has been ferociously hard because we haven't really had interactive systems that are capable of interpreting and responding to English language as if they were human. That, again, changed with GPT-3, GPT-4. And in fact, no sooner was GPT-4 released than some researchers at Stanford University decided to create a very interesting experiment in generative agents. And they published the results in April. So what they did was, taking a page out of The Sims, they created a town called Smallville. They created personas for 25 generative agents, which were all wired through the API into GPT-4. They gave them all personas and then allowed them all, through this programming, to interact freely. And they, of course, gave them their roles, their responsibilities, their goals. And behaviors started to emerge. People would connect. People would do things, unexpected things. Things that the folks who had designed these systems hadn't told them to do started to happen. And that was interesting. But now, in fact, what they did was the researchers said, let's give them something to do. And so, in February, what they decided to do was they decided to tell Isabella, who's up here in the left-hand corner, to have the bright idea of throwing a Valentine's Day party. And her friend said, I actually really want to help you decorate the local cafe for the party because I want to send an invitation to the guy that I'm really hot for. So what happens is they plan in a town of 25 people, 8 invitations are spontaneously sent out to the party. You're now wondering what's happening to the other 15 people, maybe? Of the 8 people, only 5 accepted because 3 had other things to do. And they documented all of this in the paper that was published in April. And they said, it looks like we actually have high-quality generative agents now using GPT. And the first place most people will end up seeing this is in what we call NPC, non-playing characters inside video games, which today are just stupid. They're just rote because they're really just responding to stimulus. Where we're going is that the language model will either be interacted with online by these games or will be embedded in the games with the current models, which are getting smaller, and you will actually be interacting with something that has near human intelligence inside the context of the game, which means the NPCs are in a lot of sense going to be playing the game alongside of you. All right, that's generative agents. That's our first element. Next, generative worlds. Now, before we all got crazy about ChatGPT, we were in the midst of another AI revolution, what we call the diffuser. So you have DALL-E 2, you have Midjourney, you have Stable Diffusion, which is the open source version of these. This is where you provide a text prompt and it creates an image based on the text prompt. So it's text to image via AI. And these are really interesting, and they were really causing a lot of flurry before ChatGPT. We're like, oh my God, the future of AI, it's being creative. And it's interesting. I became absolutely obsessed with Stable Diffusion because I learned in maybe a Reddit thread, maybe on Twitter, back when Twitter was useful, a very simple prompt that I could type into Stable Diffusion that would generate an endless series of really tastefully decorated men's bedrooms. I have generated thousands of these. I show them to friends, they're like, those linens, that wall hanging, none of these actually exist, but they've been generated over and over. But because I used the keyword isomorphic in the prompt, it generated them with correct 3D perspective. And I'm like, wait a minute. This is generating 3D, but it doesn't really even think about it. How far are we away from being able to generate real 3D? And the answer was about 2 weeks, because Google announced Dream Fusion, which allows you to take a text prompt and turn out a 3D model. And there's actually multiple versions of this now that are out there. And so it's like, okay, we're solving one of the big problems in the metaverse, which is that there aren't enough 3D modelists in the world to populate the metaverse with all the stuff that we're going to need. We're going to actually need text prompts to do a lot of that. So good, excellent, we need this. But there's objects and then there's spaces, and spaces are always harder too. I was like, wouldn't it be amazing if you could take a text prompt and generate space and then text to room happened? Prompts to metaverse. So you could say, okay, I want to prompt with a living room with bookshelves, couches, and small tables, and this is what you get. So it does the work now. So now, all of the heavy lifting that I thought was going to slow the adoption of the metaverse beyond just being able to deal with 100,000 people in a space together was all starting to fall within the realm of things that generative AI could make possible. Source code for that is now freely available. You can download it if you have a sufficiently powerful computer and create your own spaces with it. All right, so you have this idea now that you can have space filled with objects, and you can have the objects in those spaces. You need those 2 elements to have generative worlds. All right, so what do we have? We have generative agents, and we have generative worlds. And we now need to add a third element into the mix. So there's this whole field, which is actually quite old now, called autonomous agents. What's an autonomous agent, you ask? Well, 30 years ago, Apple actually showed us what an autonomous agent is.
Today you have a faculty lunch at 12 o'clock. You need to take Kathy to the airport by 2. You have a lecture at 4:15 on deforestation in the Amazon rainforest.
Right. Let me see the lecture notes from last semester. No, that's not enough. I need to review more recent literature. Pull up all the new articles I haven't read yet.
Journal articles only?
Fine.
Your friend Jill Gilbert has published an article about deforestation in the Amazon and its effects on rainfall in the sub-Sahara. It also covers drought's effect on food production in Africa and increasing imports of food.
Contact Jill.
I'm sorry, she's not available right now. I left a message that you had called.
Okay. Let's see.
So that was Apple's vision 30 years ago for what an autonomous agent would be able to do. And it's an amazing vision. It was going to be the foundation of what they were doing with Newton and the future of the computing on the Macintosh, but it was impossible because it requires a level of artificial intelligence that we didn't get our hands on until about the last 6 months. The day after OpenAI released its programming interfaces, its APIs for GPT-4, a project was announced in open source called AutoGPT. So this is an autonomous agent that's using GPT-4. What do I mean by that? Well, all of you in this room can install AutoGPT on your own computer because it is free and open source. You can go to the website, you can download it. When you download it, what you'll do is it will open up a console window and it will load and it will ask the question, I want AutoGPT to. In my case, I've typed in open the pod bay doors because that is the eternal question. What actually goes on at this point is you can type pretty much any request you want in plain English. What will happen is AutoGPT will take that request and turn it into a goal in conversation with GPT-4. Once it has turned that request into a goal, it will then translate the goal into a task list, again, with GPT-4. Once it has that task list, it will break each of the tasks down into a series of steps. Again, in concert with GPT-4. It will then work its way through that series of steps, turning each step into a set of actions. If those actions are human actions, it will tell you what to do next. If those actions are computer actions, it will write the code, test the code, and then execute the code. And it will do this methodically from the top to the bottom until it's done. And if it fails anywhere along the way, it will recognize it, it will go back, and it will try a different method. That's the response I expected. And you think, well, that's a little powerful, isn't it? And it is. A few weeks after AutoGPT was released to the public, someone did something that everyone needs to do when they see a new technology like this, which is to take it to the worst possible case imaginable. So this person, who goes by the Twitter handle NFTGod, said, okay, I want to create a disinformation campaign for the 2024 US presidential election. That's what he asked, or they asked AutoGPT to do. And AutoGPT went to work creating fake Facebook profiles, fake news sources, and interlinking the whole thing so that it would become a beating heart of disinformation. Now, a few hours into this, they pulled the plug. At least that's what they said. But you know there are other people who have this technology who are not pulling the plug. And we just need to be clear on that. These are very powerful technologies. They confer unprecedented power on us, and we have to be across how they're going to be used. Okay, I've now described the three elements that we need. And there's this idea from process philosophy called concrescence, which is when you bring different elements together in a unique way. So we have generative agents, we have generative worlds, and we have, coordinating the generative agents and the generative worlds, autonomous agents. So you can think of generative agents as the cast, generative worlds as the stage, and then autonomous agents as the director, the scriptwriter, and the producer. And this now comes together in what I call the syntheverse. It means that we will be able to use prompts to create detailed, useful simulations. What do I mean by that? Well, I've got a few examples for you. If you've been to law school, you know that there's this thing in law school called moot court, where you get to argue a case in front of a fake judge and a fake jury and be a fake solicitor while you're doing it. It's so expensive that you generally only get to do this once when you're at law school because it requires such a confluence of resources. Using the syntheverse, you should be able to provide the simple prompt: create a moot court, generate a tort, argue for the plaintiff, I will argue for the defendant. And everything will come together to make that happen, which means within a few years, a law school education is going to be partially in the classroom and partially in the syntheverse, because someone will be practicing the entire time they're learning how to practice law. Second example, architecture. Client brief for a new apartment block, build a walkthrough for 3D, that's easily done. Create a site plan, less easily done, because that's everything connected with how you're going to marshal the resources and the timeline for building the building itself. But again, incredibly useful. Allows people to do planning at a scale they've never been able to do before, and at such a low cost that it's going to be possible to spin up ideas at a rate of knots, whether or not they're actually useful. You'll learn that quickly. And then finally, and this points back to an example from Queensland on this stage yesterday. Create a simulated hospital emergency ward staffed with nurses and a queue of patients to be treated. I probably should say a queue of angry patients to be treated. I am a doctor. And again, it's going to do all of the work that Queensland Health probably spent hundreds of thousands of dollars on to create that incredible simulation to help people with cardiac, or to help people deal with patients or family members who are angry, regular situation in hospitals. So this is the kind of thing that we should be able to do easily and quickly when we bring generative agents, generative worlds, and autonomous agents together in syntheverse-style simulations. Now, I make it sound easy. It is not easy. And it is not going to put everyone out of work, because as we know from all of our work with generative agents, generative worlds, and autonomous agents, these things can run off the rails very quickly. They hallucinate, they make mistakes, they don't know they're making mistakes. So the more that you rely on these kinds of simulations, the greater the need for experts who will be able to check the qualities of these simulations before you hand them to people who are not experts and expect them to get useful experience from them. So the need for experts in the mid-21st century is increasing rather than decreasing because of artificial intelligence. Where we're going is back to where the spreadsheet was. The spreadsheet is actually the single most important application that has ever been written for a computer. If we didn't have VisiCalc, there would be no Apple. There would be no IBM PC. There would be no computers everywhere, which means there would be no web. The ability to simulate numbers, which is fundamental to how we operate our civilization now, is part of what the spreadsheet gave us. And the syntheverse is now going to be that, but much more fully realized. And in the same way that the spreadsheet is everywhere in our world, so will the syntheverse. All right, one more thing. The syntheverse is going to happen. And we could establish some great big X prize for some of the moonshot goals about what we want the syntheverse to do. We don't need to do that because, and I apologize for bringing this up in a public forum, this isn't actually going to be about us. It isn't going to be about what the futurists want, because the ability to take a text prompt and to create any fantasy world that you want means that it's going to be driven by factors well beyond our control. Thank you.